Okay, let's go. So let's do an example here. So the integral of 3x5 minus 7x4 minus 3x cubed minus 9x2 minus 5x minus 5 over x2 plus 1 times x minus 3 dx. Okay, so this is the integral I would like to solve. Okay, so I know right away that the bottom is factored, so chances are I'm going to use partial fractions decomposition. Okay, but the only thing what we haven't done last classes is that we didn't do an example like this where the numerator has an exponent, right? The degree of the numerator is bigger or equal than the bottom. Okay, so if the bottom is a third degree, right? If you multiply x2 by x, this will be a third degree polynomial, and the numerator is a 5 degree. So it's bigger, so you have to do polynomial division. Okay, so let's do the polynomial division. So the denominator is what? If you open everything up, okay, just for you to know, well, x2 plus 1 times x minus 3 is equal to x cubed minus 3x2 plus x minus 3. Okay, so at this point, we have to divide the numerator by this polynomial. Okay, so there's a few ways to do it. To set up division, I'll do the American way because I think most of you guys do it this way. So it's x3 minus 3x 2 plus x minus 3, and then you do like this, I guess, and divided by 3x5 minus 7x4 minus 3x cubed minus 9x2 minus 5x minus 5. Okay, and my guess is what you do now is you ask yourself how many times does x3 go into 3x5, and that of course is 3x2. Okay, so 3x2 times x cubed is 3x5, and 3x2 times minus 3x2 is minus 9x4. 3x2 times 3x is plus 3x cubed, and then 3x2 times minus 3 is minus 9x2. Right? That's what you do, I guess. And then you just subtract the top polynomial by the minus, by the lower one. Okay, so you will subtract these. Okay, regular division that you've done in high school. And so 3x5 minus 3x5 disappears. Negative 7x4 minus 9x4 is plus 2x4. Then negative 3x cubed minus 3x cubed is negative 6x cubed. And negative 9x2 minus negative 9x2 disappears. And these ones, they still here. Minus 5x5, minus 5x, minus 5. Okay, and then again, we do what times x cubed. I start over. What times x cubed gives me 2x4? So it will be 2x. And again, 2x times x cubed is 2x4. Then 2x times negative 3x2 is negative 6x cubed. And 2x times x is 2x2. And then 2x times minus 3 is minus 6x. Again, all this in brackets, we minus everything. And 2x4 disappears, the 6x3 disappear, and what's left? I have negative 2x2 minus 5x plus 6x is plus x, and then I have minus 5. That's what I have. Okay, and I'm done. The division is done because now the degree here is less than the degree here. So I can't go any further. Are there any questions until here?
So please, can you explain how you got plus 2x on the top?
2x
Yeah. Yeah.
Because I asked myself, what times x cubed will give me 2x4? Okay, 2x times x cubed is 2x4.
Okay, thank you.
Like this. Okay. In other words, what did I just say? Okay. I just said that this fraction here, okay, so this integral, okay, which is numerator over denominator, is equal to 3x2 plus 2x plus the remainder over the denominator. Okay, always over the plus the remainder over what we divided by. Okay, that's always in fraction in division. It's always like this. So minus 2x2 plus x minus 5 over the denominator, which is this, which I could write factor like this. x2 plus 1 times x minus 3 and all this dx. So that's how I'm rewriting my integral. Okay. We've got questions until here, until this step. Okay. So always, the first step, if the numerator has a degree greater than or equal to the degree of the denominator, you always do this division first. And you rewrite your fraction as this. Okay, the whole part plus the remainder over the denominator. And now this little part here, this I could decompose in partial fractions now. Okay, so there's an extra step when we have such a case. And that was one of the questions in the worksheets. Okay, so let's decompose now negative 2x2 plus x minus 5 over x2 plus 1 times x minus 3 is equal to, just like we did before. So over x2 plus 1 plus, and this will be something over x minus 3, right? So what am I going to write here?
ax plus b.
Very good. Ax plus b, because it's second degree, so I need first degree on top, and this will be a c. All right, and so now I'm going to find the common denominator on the right and make it equal to the fraction on the left. So 2x2 plus x minus 5, and this will be ax plus b times x minus 3 plus c times x2 plus 1. Okay, let's now do put some values for x. So let's put x equals to 3. What happens if x equals to 3 on the left? I get 9, negative 18, negative 18 plus 3 minus 5 is minus 2, negative 18 minus 2 is negative 20. And on the right side, I get 9 plus 1 is 10, so 10c. And so I just found that c is negative 2. Okay, let's put now x equals to 0 to get rid of the a. So left is negative 5 is equal to b, right? Is 0 plus b, so it's b times 0 minus 3 is negative 3. And then plus c, which I know now is negative 2 times 0 plus 1 is 1. So that's what I feel. Okay. And if you solve for b now, you will get negative 2, 2, negative 3, negative 3, 1. So b is 1. Are there any questions? Okay, so I have b, I have c, I need to find a. So I'm going to plug in any value. Let's say x equals 1. That's an easy one. So negative 2 plus 1 is negative 1. Negative 1 minus 5 is negative 6. And if x is 1, so this becomes a plus b, which is 1, times negative 2. And then here, minus 2 times 1 plus 1 is 2. And so you could find what a is. So I have negative 4. Negative 4 here on the other side, this becomes minus 2. Minus 2 divided by minus 2 is 1. A plus 1 equals 1, so a equals 0. Okay, so I just solved this. Take your time and solve it, but I just don't have much space, so I'm just solving it mentally. Okay, so now I could rewrite my integral. So I have 3x2 plus 2x plus, and now this fraction here, I could write using this. A is 0, b is 1. So I have 1 over x2 plus 1, and then b is b, yeah, b is 1, c is negative 2, so minus 2 over x minus 3 dx. Okay, so 1, 2, 3, 4 terms, 4 separate integrals. Okay, thanks to the linear properties of indefinite integral, and I could just integrate each one. So what's the antiderivative of 3x2? That's just x cubed. The antiderivative of 2x, that's x2. The antiderivative of x2 plus 1 is what? 1 over x2 plus 1, sorry, is what? This is the arctan of x. And minus, and here if you do a substitution, you will get 2 times ln of the absolute value of x minus 3 plus c. And that's my answer.